They're all made out of
Hello there, Squirrel here. Welcome to the Squirrel Squadron. We're playing a song called Little Boxes. I don't know whether you can hear it. I just had the idea just before that maybe we should play this. My mom used to play this as a kid. It's Pete Seeger from the 1960s singing about suburbia and how unpleasant the little boxes are that people live in. Well, welcome to my 600-year-old house, and we're going to be talking today about not keeping your developers in little boxes. So looking forward to talking to you about that. Hello to people who are watching this on a recording. If you're here live and you're wondering what I'm talking about, you'll be able to come back here and watch this this event later on the same link that you are now. So wherever you're watching this, you can come back if you have to go away or you want to share it with a friend. That's something that you can always do. And so we're glad to have people live and on the recording. Please say hi if you're here live. I'm really curious about what brought you here. Why do you care about code ownership? Are you a developer who's stuck owning some code and you don't want to own it? Are you a non-technical executive and you're not really sure what code ownership is, but your developers seem really slow and they all say, well, we have to wait until so-and-so gets back from holiday. That would be an example of code ownership that we're going to talk about. Or are you a manager of developers and you're caught between those two? You're wondering, how do I get my engineers to be more flexible? How do I get the rest of the business to let me get some expertise into my team? How do I do those things? Give me a quick shout in the comments. I will be able to see them. I'm very curious about what brought you here, because if you don't ask me any questions, if you don't tell me what you came here for, I'm going to cover a bunch of stuff that I'm interested in. I'll have a great time. But you may not get what you want and we'll be done sooner. That's fine. I can go walk the dog. But I think you might like to get more information, more ideas, more suggestions. And I'd love to have your examples and your stories included. Okay, very brief introduction to the Squirrel Squadron. And me, I mean, I'm Douglas Squirrel. You guys must know me. If you don't, go look at squirrelsquadron.com, where you can see a lot about me, the hundreds of organizations I've worked with, and the 2,000 people now who are in the Squirrel Squadron forum. The forum and the events like this are part of this community that we have of tech and non-tech people together, which is, I think, a very unusual thing. I don't know any other communities that bring those groups together. There's lots for CTOs and CFOs and CEOs and people like that. But where do they come together to talk about how to make their tech insanely profitable? Well, the place they do that is the Squirrel Squadron. We have a forum, as I mentioned, with lots and lots of different discussions on there. I just had a look at what was there. We had recently discussions about how to measure your team, even if you don't know anything about technology. That was part of a live event that I did in London. And have people showing their examples of drawing a tech radar, which gives you a sense of where strengths and weaknesses exist in your team. And you don't have to write a line of code to use it. And we also had a big discussion about budgeting and how to make sure that your budget works well and your engineers don't run over their budget for time or for money or for something else. How can you avoid kind of death by 1,000 cuts? So that's what's happening on the forum. And we have more events coming up. So if you like this one or you're interested in these topics, please come along. That's at squirrelsquadron.com/events. And on there, you'll find us talking about how CTOs and CFOs should collaborate. It's not just when there's time to get some money or to hire some developers. They should be collaborating a lot more. Talking about how to interview technologists, even if you don't write any code. How can you make sure you hire highly skilled people? Hint, you'll probably need some help, but there are some things you can do to get that help. And we will be doing lots more there. I think we have them booked all the way up through the end of January. So lots of interesting stuff coming, and just as easy to come to as this. All this is free, by the way. It's my way of giving back for all the wonderful stuff that my clients have been teaching me over many years. Okay, so let me just get started here on the topic of code ownership. And what I want to start with is very long ago history. So when I first started as a developer, we were writing in the C programming language. People still write in that, but it's a lot less prevalent than it was then. And we were designing a lot of pieces of software that today you would just buy. So we didn't have browsers, for example. So we were designing all the things that went onto the screen in the way that, and the browser now does a lot of that for you. Chrome or Safari renders your application. And we had a way of building that code, a way of making the software that was prevalent at the time, but almost no one uses today. And that was that it was almost like a library of code. So you'd go to the library and you'd say, I would like this piece of code. I like the code that deals with displaying pictures in a box on the screen, like the one that you're looking at with me in it right now. And I would like that code, please. And when I take it out, no one else can have it. Just like in a library, if I take out a book, no one else can have that book. Now, the library might have multiple copies, but this library didn't. It had just one of each. And so if I wanted to work on the code that had to do with displaying video, then no one else could work on that. And if someone else wanted to work on the code that dealt with passwords and usernames and things like that, no one else could deal with that. So you can imagine what goes wrong with a system like this, where you check it out and hold it. Sometimes people go home, or somebody checks it out in England, and people who are working in California are not able to get hold of it, and they can't just walk over and tap the person on the shoulder and say, would you please let me use this piece of code? So we had terrible dependencies and terrible slowdowns, which we didn't even realize we were getting. We just thought this is how things work. This is how code works. And, you know, we've been going to libraries for a long time. So we're going to take something out, we're going to work on it, and then we're going to put it back. And that gave us a lot of integrity. We were sure no one was going to change the same thing in two different ways, but at a huge cost in productivity. And no one does that anymore, or at least I really hope almost no one does. Maybe in highly secure situations or something like that, you might have that level of control over who accesses code. But I really hope none of your engineering organizations are working that way, because we've kind of discovered how to work on multiple pieces of code and multiple documents at the same time. Many of you probably use things like Google Docs. I was just collaborating in one of those earlier today with a colleague in Iowa. And so he can make some changes and I can make some changes, and they might be incompatible, but the system figures it out and points out to us where they need to be merged together, where we need to make them match up. So it's entirely possible these days not to work in this kind of checking out library mode. The problem is lots of engineers still work that way. And so if you have the feeling that your engineers are working in this way, where there's only one person who can work on one thing at a time, certain people have specialist knowledge and only they can work on certain things. And even if someone knows about something, they can't work on it because someone else owns it. It belongs to them. Now, there's lots of shapes this can take. The most common one, which I'm not going to talk about as much today, is where you have front end and back end and data teams. You have teams that are named after and responsible for and own certain types of skill. So the back end people are going to be dealing with databases and where data is stored and how it's cleaned and that sort of thing. What happens with common usage. The front end people will be dealing with what's happening on the screen, whether that's on a mobile screen or inside a browser or old school on a client on the desktop. They're going to be owning what people see and how they work on it. There might be a data team who's dealing with the data coming in and out. There might be a model machine learning team that's dealing with the artificial intelligence that everyone's so excited about. And each of those work completely separately, and they are not allowed to touch each other's areas and typically don't want to and don't have the skills to do so. And therefore, you get huge amounts of handoffs. You get the front end people waiting for the back end people who are waiting for the data people. And then when these guys finish, these guys are too busy. So these guys still have to wait. And you get a very slow, high dependency system. So I railed and ranted against that one in a recent event. If Laura happens to have that to hand, maybe she could stick it in the chat. It's an event on cross-functional teams and how much you can do cross-functionality. So your team actually can have front-end and back-end and data and marketing and customer service and a whole bunch of other people. So there's lots of ways to make the people who are working on a problem much more able to work on that problem and much more flexible about how to do that, so they don't have to be divided into these silos. So I'm not going to talk a lot about that unless you guys ask me. So as I said, stick questions in the chat, stop me, say, hey, wait a minute, Squirrel, I don't agree with you. I don't believe that. So if you have questions about that, tell me. And certainly check out the previous, I'm pretty sure it was a live stream on cross functionality, because that's one way of having code ownership that I'm not going to talk about as much today. But there's another common kind of code ownership. And this is one that sort of superficially seems better. People can kind of understand that assembly line model, well, I have to finish the data, and then I have to finish the back end, and then I have to finish the front end. That's easy to understand, but very slow, because there's this dependency. It's sort of a linear process. And you'd much rather you could work on it more fluidly. How could I get a whole problem solved for a customer? So the interesting thing is that when people say, I'm going to do this better, they often say, what I'm going to do is set up my teams by product. And, I have one product for administrators, and I have another product for my typical end users, and I have another product for my super users. And so I'm going to have the super user team and the user team and the administration team. And I think, isn't this a whole lot better? And it is better in the sense that if you want to get a feature out to your super users, well, you hand it to the super user team, they have front end and back end and data, and they have all the different things, then they can work on that and they can get that feature in place. And your super users say, hey, this is great. We don't have to wait for all of those steps. We can just get moving and get something that we can work with. The problem is that you still wind up with code ownership, that you have separate products. And I'm imagining in this situation that you have separate pieces of your software that do these different jobs. You might have pieces of software that are for different markets. You might have enterprise users and mid-sized businesses and small businesses. You might have people in Germany and people in the UK and people in the US. And each of them have different separate bits of code that do very different things for each of them. And if that's the case, you have code ownership. Because what happens is that the people who are in charge of, say, the super users or the German users or whatever it is, that particular piece of code, well, if they want to build something that affects the others, if they've done something neat that actually is useful to the others, it has to get replicated. They can't reach over there into that other code. They're not allowed to. At least the title of their name of their team doesn't seem to suggest that they can. So they're not going to reach over there and say, great, I'm going to build now something for the administrators. I'm going to build something for the US. Hey, wait, we're the German team. We're not allowed to touch that. So the problem there is that you get not dependencies, because the teams can get things live, but you get silos of knowledge and silos and often repetition of bits of code. So we'll build one for the German market, one for the Chinese market, and one for something else. Build one for the big customers and one for the small customers. And there's huge amounts of overlap, and you're wasting energy and slowing yourself down and duplicating work in a way that's very ineffective. Plus, your engineers don't learn from each other. So if there's some really cool idea that people are using in the enterprise software, well, the retail folks are not going to hear about that. And this gets even worse, of course, when you get people on different continents and working in separate locations, and they never really talk to each other. And suddenly you have this balkanization, which is very similar to the front end and back end and data and so on. Not because the teams are necessarily so dependent on each other, because there's just no traffic. There's no cross information flow. So that's what code ownership feels like. I imagine that you're seeing that you don't need to be a coder to know that. If you go talk to a few engineers, you talk to them about what their limitations are and what they're allowed to do and where they sit, and you just look at the names of the teams, you'll see pretty quickly whether you have this particular problem. So if you're not familiar with code, don't worry, you don't have to go look in GitHub or something like that to see this. You have to see the behavior of the engineers. That's what helps. Now I want to tell you a story. So we got Laura putting bits in. And Jay says, please do. Well, I hope I did do whatever it was that Jay wants me to do. I can't always see what the context is. Sorry, folks. But Jay, I hope I'm doing what it is you're after by telling these stories and giving you this detail. So I want to tell you a story about John. And John used to work in the warehouse at the e-commerce company where I was CTO. And at one point, the warehouse was owned by the company, and then they outsourced it, which is a smart thing to do. Warehousing is a pretty complicated job. We were better at the selling end than the warehousing end, so we gave it to someone else. But of course, we still had people who cared about the warehouse. And John came from being actually walking around and moving things from shelf to shelf and running that warehouse. He came to be in our office. And he sat at a computer all day, And he phoned the warehouse, and he'd sometimes go over there, but most of the time he was sat at the computer, and no one had any clue what John did. We just had no idea what at all he did. By the way, this is an example not of code ownership, but of sort of product ownership, because this problem can happen in lots of places. So I'm illustrating that this can happen in more than just software, although that's obviously my focus today. So John had something to do with the warehouse. He did something in the software all day. It was he told us it was very important, and the goods would not get to the customers unless John was doing his thing, but no one knew what it was. So one day I went over to John and I said, "Would you just show me what it is that you do? I'm really curious." He said, "I remember this." He was so firm about it. He said, "Squirrel, I have my job and you have yours. So you go back to your desk." So I said, "Okay," I got told. And he went on holiday and he continued doing it. He'd take his laptop on the beach and he'd sit there and do whatever it was he did. And we couldn't work out what it was. And this was a big risk to the company. So this is another illustration of the sorts of things that happen when you have code ownership or product ownership. You have this dependency on a person. How do they go on holiday? How do you cover for them? What happens if they quit? And we got quite worried about this because we didn't really understand. He wouldn't tell us. He wouldn't tell the CEO. He wouldn't tell anybody. And so what we did, of course, is we stuck in some analytics. And this is pretty easy to do in a browser-based application. You can just stick in bits that will log for you what the person is doing. So we'd say John logs in, John goes to this screen, John enters these numbers, John updates these other things. And we went through all the things that John did in the log file. And we figured out there wasn't very much that he was doing. And a lot of it duplicated other things, and some of it was wrong. So once we actually understood what John was doing, we wrote it all down, we gave it to other people to do, and we fired John. So that is a story that doesn't end very well for John. It wasn't also very good for the company. It would have been much better if we'd not got ourselves in that situation. So I tell you that story about a non-coder so that you can recognize what this looks like in any circumstance, right? You do not need to understand the software to see that. And I'll tell you more stories as we go of engineers who are in this situation and what it looks like. Because it's important to be able to recognize this. It may not be obvious if you're not in the code every day yourself, but the signs are pretty clear. And the effect on the business can be very large, because what you wind up with is not only this kind of dependency on one or two people or a team, so that team has to continue doing that work, but you also are missing this cross-pollination. You're missing information flow. You're missing opportunities. You may have more efficiency because somebody really knows that code deeply, but you don't have enough people who know it, and you don't have enough new ideas coming in. So that's what code ownership looks like, and some of the dangers of it. But now I want to tell you a little bit about sort of how you might get in this situation, and what you can do along the way to avoid it, and what you can do once you're in the situation. So the John example came about because he was in the warehouse doing his thing. Nobody saw him. And then he came back to the office and he did whatever it was, and we weren't observing it as it went. More commonly in code terms and software terms, what you'll have is kind of a gradual process, a boiling of frogs, if you like that analogy, where you don't start out with code ownership. You start out with people being able to work wherever in the software they want. You don't have this kind of checking out notion. Well, this belongs to me. Only I can work on it. You can't touch it. It's all mine. You don't start that way. But you kind of get there because somebody gets to know a certain area, and then they do more and more to it. And I want to illustrate that using something from 2,000 years ago, maybe even more. A guy called Ptolemy invented a system. And it was a really logical system, made tons of sense. And it was for knowing where the planets were in the sky. And Ptolemy said, well, look, it's obvious. We're here on the Earth that's not moving. And you look up in the sky and you see these objects moving around. And we can track where they are, and we know how long it takes. And they move around in big circles. So what we're going to do is just draw a bunch of circles. And we'll keep track of where all the things are. And we'll look there, and we can see how many, how far around the circle it is. And then if we want to know where Saturn is, we just go, there's Saturn. Very simple system. That made a lot of sense to Ptolemy. But then some people started to notice there were things that didn't work in the system. For example, Saturn starts going across the sky like this, but then it stops and goes backwards, and then it goes forwards again. And various other odd things happen in the movement of the planets. Of course, we all know that's because the Earth is not stable. It's not stationary. It's actually going around the sun, and we're catching up and falling behind the other planets and other things. But they didn't know this. So they said, people came after Ptolemy, said, well, gosh, don't worry about that. That's fine. What we'll just add is a few more circles. So the Saturn's going to go around, but it's also going to go around in its own little circles as it goes around. And these are called epicycles, these extra sort of movements as the planets go around. And they said, well, this must be what happens. So we'll just kind of keep track of Saturn. Now it has to do kind of extra circles as it goes around. Go look up pictures of this. It's fun to see how complicated this stuff got. And as we keep track of these extra circles, then we'll know where it is, because it'll go backwards and forward. And they said, yeah, except every 7 years it does something else weird. So actually, most of the time this thing works, but it doesn't work here. And so they kept adding more and more of these. I think they got up to 4 or 5 layers or something by the Middle Ages, just trying to keep correcting this model. They kept trying to make it better. Now, why am I telling you this story? That's not because Ptolemy owned any software, right? But it's because this is a very common kind of thing to happen when you are building a piece of software and learning about it as you go, which is always what happens, right? We're always building software that we don't quite understand. Our users haven't quite told us everything about it because they don't know. And we find all kinds of little pieces to add to it. This happened to me. And that's what made me think of it as I was preparing today. I was building a piece of software with my team for finance. We were tracking the performance of certain stocks in the stock market. And as we were tracking the performance of that, there's all kinds of complicated ways that you measure the performance, and people who trade in the market really care about exactly which one. And if you're off by a 0.5 percentage point, they really notice, and they phone you up and scream at you and throw things at you until you fix it. So we started with a kind of naive way of measuring. Well, we bought the stock at this and we sold the stock at that, and therefore the difference is how much money we made or how much the stock has moved in that period. But that wasn't good enough, because we also needed to measure what happened if the stock split, what happened if there were other actions that happened that affected the share price, what happened if trading was stopped. So all these little things came along, just like the epicycles, right? We had the basic circle going around. Hey, we can just subtract where we started from where we ended, but actually it's not that simple. So we kept adding more pieces. And it got more and more Byzantine, more and more complicated, because the calculation just did more and more and more stuff. And at some point I realized that I had no idea how this was being calculated. We had a piece over here that did this thing, and we had something else that only ran on Thursdays, and something else that it only operated if the moon was full. And we'd all added all these little bits on there. And there were a couple people who understood this. And I was not one of them. I was the CTO. And I said, this does not seem very good, that we really don't understand how this is done. Now, we thought it was okay, because the traders who had been screaming at us, phoning up and saying, fix this and deal with that, and here's the other problem, they had stopped screaming. So we thought we were actually okay. But that made me feel a great sense of risk about the state of this, because I had only a couple people who understood it, only a few people who could work on it, who could check out the code and do something with it. Because anybody else would just say, oh my God, this is too complex, too many epicycles here, right? Too many little calculations, special cases. I don't understand it, and therefore I can't work in it. But don't worry, because those people over there know. But there weren't very many of them. And I didn't have tremendous faith that they had it right. Neither did they, right? They said, hey, we just kept fixing this, just like Ptolemy did. Now, you might think that the solution is the same as in the case of understanding where objects are in the heavens, and that was to crumple it all up and throw it away. And our friend Copernicus and Galileo and Newton came along and said, actually, maybe we go around. Maybe things run in a slightly different way. Well, that was not the solution, and it is not typically the solution in software terms, because unlike science, we are really kind of discovering how things work, and there is no right answer. We can't, send a rocket ship someplace and say this is how you actually should measure share prices, in the same way you could send a rocket ship out and say, well, actually, here's where Mars is, and here's what's happening. So because there wasn't this sort of ultimate source of truth, what we did is that we stabilized and improved this software by removing the code ownership. So what did that mean? It meant that when somebody said, I don't understand this code, I'm having difficulty working with this code, we didn't let them get away with that. We said, okay, great. You're going to pair up, and this is one of the key techniques. You're going to pair up with one of the experts, one of the elders of the tribe, one of the people who really knows how this stuff works. And you are going to work with that person. And what you're going to do not only is to make the change, whatever it is you want to add, yet one more epicycle, whatever bizarre thing you're going to do, but you're also going to make it more comprehensible. So you had two people working together at the same computer. This is a process called pairing. Your engineers should know how to do that. If they don't, send them to me and I'll help them understand. But it's a common technique, well known, and a good place for people to learn, because you get a person who knows all about it, and another person who's learning, and maybe the person who's learning types and the information gets into their brain while the other person is making sure that they understand it. But also their mission was to make the code more comprehensible. And the main thing we used for that was tests. I have a number of different previous events and recordings and things on how to write good tests, what tests should look like, how you can understand tests, even if you're not a coder yourself. So I'm not going to go into depth on that unless you guys ask me about it. But what happens is with the result that we had once we started doing this was that we had a comprehensible set of specifications for what this thing should do. And we were able to say, well, actually, it does this on Thursdays and it does that on Fridays, but actually it should do that every day. So there's an error. We've been wrong 3 days out of the week. And we have two different implementations of the Thursday and the Friday. We should fix that. And once that became evident to us through the process of testing, through the process of pairing, just explaining it to another person, and explaining it on a real change that somebody actually wanted us to make, we got more and more control over this process, more and more understanding of how this calculation occurred. And I slept better because what I was able to do eventually was to say to any new joiner, well, go work with so-and-so for a bit, read through the tests, make sure you understand this. Now, it was not simple. It never became simple, but it became comprehensible. You could get your arms around it. And the key metric was, it wasn't only just those 2 or 3 elders. It wasn't the people who had been there at the beginning who had hacked around with this thing and kept adding more and more complexity to it. It was anybody really could go and work on the code with enough perseverance, with enough information, with enough willingness to investigate, because it was complicated, but the knowledge was there and it was shareable. Now, I just want to encourage you again, please ask questions if you have them. I'm having fun chatting about this. I hope this is useful to you, but some feedback would be great. Jay is out there saying, please do it. So Jay, tell me what it was I was supposed to do, and I hope I'm doing it. But the same for anybody else who wants to comment. I'd be very interested in what you think, whether this is useful to you, what questions you came with. I did notice in the forum, I ran a poll there of asking what their teams were structured like, what they were actually doing. And most people said that their teams were in one of these kind of balkanized states where they're working on separate products, separate activities, and they don't really communicate that much. They'll collaborate if they have to. And what I'm encouraging you to do is to break that up, to change that. And I've just told you a story about how to do that, which I hope is helpful to you. So let me just illustrate a couple things that are important that didn't come out as much in that story. And that is that when you are when you're seeing this kind of code ownership problem, what do you want, what might lead to it? What could you do to reduce it to start with? And what can you do to minimize it, to make it go away, to reduce this duplication, this confusion, this lack of flexibility among your engineers? Well, one of the things that's a huge contributor to this that we didn't have at the company I was referring to is lack of seniority. So if you have lots of junior folks, lots of people who have come straight from university, they might be interns. I was working with a Canadian company the other day. They're called co-ops there. If you have very junior people who've never really worked with software in this way, when someone says, hey, just add one more thing, they say, great, I'll add one more thing. If someone says, hey, work in this complicated code, they say, well, I don't know how to work in complicated code. I've never done that before. And I'm certainly not sure how to add a bunch of tests and make it more comprehensible and so on. So we better let those smart people do it. And I'll just sit over here and do something less interesting and less valuable. And that's not a very good situation to be in. A lot of companies come to me saying, we have loads and loads of engineers, way more than our competitors, and we seem to get less done. A very common problem is they've got a lot of junior people working in very complicated code, and they really can't do it. And that's not their fault. It's because the company has hired the wrong people. So looking out for the level of seniority of your team, this is one of the key metrics I use in evaluating any team. It's part of my tech radar, another thing you can look up if you're interested. And if you look at the metric, how senior is the team, almost always it's too junior. I see very rarely companies that have too many senior people. But the very common error is to say, I need engineers, they're expensive, let's get some cheap ones. Does not usually pay off, especially when dealing with these complicated pieces of code, the bits that tend to wind up having code ownership. Right, so I've already mentioned tests. I just want to underline that again. If you don't have tests around the bits that are complicated, you're going to get code ownership, because the engineers who kind of are brave enough to venture in there are the ones who wrote it. Will have a mental understanding of it. They will have a model of it that they can use, and they will be able to wade in and make changes. And other people who try will get pushed back. There's really nothing that tells them how it works. Now, sometimes people say, oh, don't worry, Squirrel, we have great documentation. We have wonderful use cases and user stories and super information that's written on pieces of paper about this software. That's great. If you have that, you're better off. So don't burn it. But there's a couple problems with that. Number one, documentation gets out of date. There's no reason why this document that you wrote a month ago or a year ago will match how the code actually works. So that's one of the problems, and that'll confuse people even more. And they'll say, oh my God, the documentation's out of date. And somebody who knows it, who understands it, will say, oh yeah, that's the change we made a year ago. We forgot to update it. Well, that's all right. I'll go change it. I'll go update it. And they don't change the documentation. I mean, they change the code, and then it becomes even more out of date. So that's where you get this kind of dependency on secret knowledge, even if you think you have this explicit knowledge. And the other problem with the documentation angle is it gives no pressure whatsoever to improve the design of the code. One thing you get when you get tests is you have to force yourself to divide things up and give them at least reasonable names and give them some kind of comprehensible structure. Whereas if you just can write the code any way you want, as long as it does whatever it's supposed to, then you have no kind of constant pressure to improve. So I find that when teams add tests, they improve their design, they improve their understandability, and they improve the ability of engineers who are new to that code to come in and work on it. I should say this, by the way, also about the test part of it. I said the documentation can get out of date. Why can't the tests get out of date? Well, the engineers in the room know, but it might not be obvious to other people. The tests are running all the time. And so if the tests fail, then you know that the test, whatever it says the software is supposed to do, well, it doesn't do that anymore. It might be the new thing is better, and you want to change the test to match how the code works. That would be fine. But they're always in sync because the tests are running. If the tests pass and the test says, should add 10% if there's a corporate action of type ABQ, then you know that the code will do that. Or if the code stops doing that, you'll be alerted. You have to say, oh yeah, it's actually been raised to 11%. Let's change it. So the point is that tests are always in sync, and they put a very positive design pressure on your code to help you to actually make it accessible. Now we have questions and comments. Stuart asks about opting for feature teams. Will that help cross-pollination? You've got Android and Apple teams consuming the same APIs. And he's saying he's worried that you might, I'm actually not sure I follow. Yeah, he's saying if I have feature teams, which I'll explain in a second, for any who might not have seen it, how do you avoid having balkanization? I think I follow now. So a feature team is a team that can work on any feature. And typically, if you do this model like I described it, and as you'll find on featureteams.org, if you follow that model, you'll probably name them after things like the goldfish team and the what are other fish? I can't think of any. Salmon team and the cod team and so on. And you'll name them after something like that, not after products, because they can work on anything. And they're cross-functional. They have all the different components. They have the ability to work on anything all the way through and deliver it. And Stuart is saying, well, wait a minute, couldn't you get this same kind of division where they become specialists? Well, there's two things, I think, Stuart, that help prevent that in that particular model, which is one reason I like it a lot. One is that because the feature teams can work on anything, they're not tied to a certain product. And so they'll probably wind up working on the calculations. And then next week, they'll wind up working on the authorization. And after that, they'll work on the configuration screen and so on. So they'll wind up kind of getting a tour of the application if you do it well. What you don't want is to let the feature teams become kind of stagnant. And, oh, yeah, well, this feature team, this team, the COD team, always works on the login process. So really, they're the only ones who understand it. So, yeah, we have a login feature and they're busy with something else. So I guess we got to wait. And that's not good. If you see that, you haven't been doing it the way I would encourage you to do it. The other thing is the same as what I've been saying. Well, and Stuart says, of course, you can rotate team members. That's always a very good thing in any team structure. And it's very helpful in a feature team structure so people can learn from each other and see other bits. But also what I'm saying here is what you don't want is to lock off certain sections. What you don't want is to lock off certain parts of the code and say, well, this feature team is really the only one that knows about this. So we're going to give all the database work to them because they've got a SQL expert, somebody who can really tune the database, people who know all about this. That's where our expertise lies. You don't want centers of expertise or centers of excellence in this area. They're good for other things, but not for this. So as long as you make sure that the code is structured and the way I was just illustrating, and it's inviting and easy to work with, it's structured well, and that you don't have kind of cultural or political or structural barriers to people working on it, then you'll find that the feature teams can jump back and forth between them. I hope that's helpful, Stuart. Ask more if you want to. And oh, Anastasia. Wonderful question from Anastasia. Let me put that on the screen here. If I can. There we go. So Anastasia, welcome. Thank you. And wonderful question. Is it a good idea to rotate engineers that specialize in different programming languages? This is one of my favorite things that people really get hung up on, including the engineers themselves, because people think, well, this person speaks Python, therefore they cannot possibly speak Ruby. This person knows this dialect knows MySQL, this database system. They can't possibly understand Postgres. This is just not true at all. You should think more of programming languages more like, so I'm going to really annoy some of you here, more like Romance languages, right? If you show up in Spain and you start speaking French, a lot of people will understand you because those languages all come from a very common, very similar root. And a lot of the words are very similar. Some of them fool you and some of them aren't right. But a French speaker and a Spanish speaker can kind of get along in a way a French speaker and, say, a Chinese speaker really can't. Those are completely separate languages from very different sources and very, very different in a lot of their characteristics. So you should think of programming languages in that way, that they're much more interoperable and much more interlearnable than engineers will let on. Now, I'm going to come to this in a moment, but I'll just anticipate it. I'll foreshadow here. For Anastasia, there's a certain type of engineer who says, look, I only speak this language. I don't care. I'll be even more stereotypical. You might think of the French, right? We speak French. We know how to speak French. French is the right language. We have a whole academy telling people how to speak French. French is the right thing. And there are people who have that attitude to Python or Ruby or C or Haskell or whatever their favorite programming language is. This is the one true language. I only want to work in it. The others are not so good, and we should only be speaking this one. And I don't want to learn anything else. That kind of engineer you don't want in your team. So people who are really attached to that and really rigid in that way are not effective software engineers, or at least not as effective as they could be. So you want to create a culture in which people say, oh, that would be interesting to learn that language. I don't know it as well as I'd like to, but I can kind of understand most of it. I can certainly read the tests. I can certainly pair with somebody on it. And I wouldn't mind learning a bit more of it so that I can be helpful. So Anastasia, it is absolutely valuable to rotate engineers onto different programming languages with care, right? You don't want to just say, hey, go dive into this complicated area in a language you don't know anything about and get it done by Friday. That's not so helpful. But giving them pairing partners, giving them training opportunities, giving them books to read is very helpful. Some of the very best programmers I've ever hired did not know the programming language of the team they were joining. I hired a Ruby developer to join a C programming team, I think. I hired a Python programmer to join a Java team. And they were able to go and learn the things that they needed to learn in order to be effective in that language. And that's what I tested them on. In fact, I'm doing a live stream in a couple of weeks on how to test in a language agnostic way, even if you're not a developer yourself. So that might be interesting. Anastasia, wonderful question. Really appreciate it. Stuart says, that makes sense. I was worried about teams that get locked into very specific parts, checkout or catalog. Yes, exactly. That's what I mean. Don't get them locked in. And this requires management attention, and this requires cultural bias and structuring, so that people have a reinforcement that it's good if you try different things. If you're always doing the same thing, if you're getting bored and you're the only one who knows that that's bad, you should do something about it. That's a cultural message that you can give. Now, that is going to bring me on to one more thing, but I just want to make sure to include one more sort of signal, one more thing that you can use as a kind of positive pressure to put get the team moving in the right direction and tell them they should. And that is surprisingly use of artificial intelligence. So many of you know, and some may not, but it's good to know that engineers are increasingly using tools like GitHub Copilot to get things that are essentially ChatGPT and their friends, these large language models, to write some of the code for them. Now, you might think that's going to be even worse. Wait, the artificial intelligence is going to write the code. None of the engineers will understand. That's not the case. If engineers use AI effectively, what they are not doing is just saying, hey, you go take care of this, you write all the code. Anybody who does that is likely to go out of business very quickly, because the artificial intelligence is not very good. It doesn't get the code right. So you need a human being looking at what the code is written, but it does a lot of the grunt work for you. And it'll produce a bunch of code, and you say, I have to fix that, and I have to change that. And, oh, I didn't know that you could use this tool in this way. And so you learn things from it, and you get improvements. The thing is that artificial intelligence is more effective in code that has good tests, that is well-structured, that has good names, that has all the good design characteristics that you would like good code to have. And it can actually work with it. If you give it some Byzantine thing with strange bits, the equivalent of the epicycles, right? Something that's terribly complicated, the computer gets confused. It's already hard enough. They're not very good at it to start with. And you give it something like that, and it just does a terrible job. So a good metric is, hey, can we actually use this stuff? Does this actually make us more productive? Or does it just get confused and give us rubbish code that we have to throw away? And the thing you can do is to say, let's use this in an effective way. Be very careful about security, by the way. So there's some big security issues that I'm not dealing with here today, unless somebody asks. But assuming it's okay in your domain to share your code in this way with a language model, and you get very useful results from it, that's a good thing, because you want to keep doing that. So you say, all right, good, we're going to use it. And where it's not useful, that's going to be a signal to us. Hang on, we've got some code here that's not well structured. We have kind of nascent code ownership happening here. Only a few of us humans understand it. Let's teach the computer to understand it. If we can get there by building good tests, having good senior engineers work on it and improve it as they go, we'll have good results. Now, I realize I didn't write down in my notes one more of these factors, one more thing that can help you understand how to keep your code effective, how to keep your code not owned and capable for, let's say, intervenable, right? That somebody else who doesn't know the code can dive into it and start making use of it. And that goes along with the senior engineers. And it involves a word that is often misused. The word is refactoring. So senior engineers know how to do something as they work on pieces of software, as they're trying to make improvements that are meaningful to customers, improve bits, add new calculations, whatever it is they're doing. That the thing that they do is very small changes that take seconds, minutes, very small amounts of time to make the code gradually better. Now, what unfortunately has happened since this word was invented and started being used, I think, by Martin Fowler, is that engineers said, oh, great, now I have a name for what I'm doing when I completely change everything. When I go into the software and I make everything completely different and I rewrite it all, and it takes me months and months and months. And they say, oh, don't worry, I'm just refactoring over here. Now, run away if you hear engineers talking about refactoring that takes more than a minute or two. And by the way, also tell them to come talk to me, and I will give them some education on what they should be doing. So whether you're technical or not, use refactoring the right way. The idea is that you make tiny changes, and a lot of them add up to significant changes, but they're each a tiny, tiny change. And as you make all those tiny changes, you improve the maintainability of the code, the understandability of the code, the testability of the code, and you break up the code ownership. You keep code ownership at bay. So senior engineers know how to do that. If they don't, they can learn quickly. Junior engineers really struggle. They just haven't got enough experience to be able to do it. So what you want to be looking for is that true refactoring, you might call it, where you make lots of little changes and you're doing it as you're doing something else that's of value to the business. And you can ask your engineers whether they're doing that. You can observe whether they're doing it, whether they're improving crufty areas of the code, whether they're making it more possible for more teams, more people to work in it, by just seeing whether they actually get that result. If they tell you, hey, wait a minute, what I have to do is be like Copernicus and Galileo and folks, and I have to tear everything up and start again, don't do that. That's usually very dangerous, because it's much better to make lots of little changes and improve along the way while you're improving it also for the customer, rather than to disappear into a corner and make it better. Because unfortunately, when you spend a long time making it better and you don't get feedback, it's often not better for the customer, and not better in terms of design, maintainability, and code ownership. Okay, so now I think I've covered all those factors, which were seniority, tests, AI, and refactoring. And now I'll come to some more comments. So Jovan says something in French, and I have to say my wife's the one who speaks French. Ich kann auf Deutsch sprechen, but I'm not sure what he says. But it has moi in it. So hope that makes sense to somebody. Dan says, the front-end, back-end division seems to come up often, either into teams or within teams. Despite trying to fight it in teams I've led, it comes back. Dan, I've been fighting this for at least 10 or 20 years. I was trying to think, when was the first time I hit this? Because back in the day when we were doing that code checking out and we were writing in C, we actually didn't have this division. So this division has come in, especially as we've used more and more browsers, as the front-end code has become more and more complex, as we've branched out, of course, into mobile development. We've wound up with this kind of specialism, which I think is very damaging. And it used to be that you would just ask a developer to change the system, and that would, of course, include changing where the buttons were and what the forms were and whether the dropdown had 4 or 7 or 12 elements in it, and also where you'd store that data and where it came from. And you just ask developers to do stuff. That's how it used to be. And, I'm old enough that I now can say, hey, kids, get off my lawn. You need to be working more broadly and more generally. And the good news I have for you, Dan, is there are engineers who like doing that. And a common name for those engineers is full stack engineers, but they don't have to have that title. Lots of folks who, for whatever reason, have been trained or have got used to working in one area would like to work in another. It's actually good for their careers. It makes them more flexible, it makes them more valuable. So it's a good career move, although some folks just don't want to do it. And that's the kind of engineer you don't want to hire, which is my next topic. That one of the great things that happens when you break up code ownership, when you get rid of this idea, when you change your culture in this way, is you drive out some people who don't want to be flexible in this way, and you don't want them. Because unfortunately, what happens is exactly what Dan's saying. He's been fighting it. He's been trying to get front-end people to work on back-end code and the other way around, because it would be so much more flexible, and you can't do it. They just won't. They won't comply. Now, some folks who initially say no, when you kind of get them, put the toe in the water, they say, oh, actually, this is more interesting than I thought. And other folks, that's how they want to work. And they should work at gigantic organizations that have, their front end on one continent and their back end on another continent. And if you work at one of those, please hire me, because I'd love to work with you and learn more about how that works, because that's not my typical environment, the Facebooks and the Googles and so on of this world. They're very interesting. They have a whole set of different problems. And if any of you guys are watching, I'd be very interested in how you solve this problem. But most of the rest of us who live on planet Earth, who have normal size technology organizations, I'm sure like me and like my clients and like Dan, our situation is one in which we want people who are more flexible. And building the software in this way really encourages that flexibility, because it makes it very uncomfortable for somebody who wants code ownership. Now I'm going to tell a story about a team that had that attitude to code ownership and what happened to them. But let me deal with a couple more questions. LinkedIn user sends something long. Let's see. What happens to improvement that isn't pure refactoring, isn't enough to mobilize a team? Assign their teams by initiatives. Parts of their product had various small user annoyances, never made it onto anyone's to-do list. Now that's a separate type of problem. It's a great question. I'll deal with it. But it's a little off our topic today. But the problem there, of course, is a product problem. So far too often, the smaller things that you might want to improve, which any engineer could work on. We don't have a code ownership problem there. We have a prioritization problem. man, I'm working in these teams, and the teams are working on the bits they're doing, and they're getting prioritized to work on this stuff. But the poor customers over there screaming that all the buttons are hard for colorblind users to use, and they have a lot of colorblind users, and all the colors are terrible for red-green color blindness, and nobody ever pays attention, and this poor customer is suffering over here. Well, somebody in the product team needs to get some clear understanding. How important are colorblind users to our user base? How important is that client to us? What value do these small improvements have? Man, we're so annoyed that our forgot your password process is convoluted and fails a lot, and people forget their passwords. Well, how often do people forget their passwords? Maybe it doesn't matter, because it's just one or two noisy people who forget their passwords a lot, and the others, it only affects them once a year. That's a product decision for any of these kinds of small improvements. And so I'd hand that back to the people in the product team and say, if you're not prioritizing this, why not? It's separate to what the skills of the engineers are, or whether they're set up to do refactoring. What I really don't like is when we artificially say we're going to spend 10% or 20% of our time on small improvements. That's just saying, hey, we don't have enough discipline over here in product to decide that we should do that much or more or less or something else. So I'm going to stop on that one because it's not our topic today. Fantastic question. I'm sorry, I don't know who you are. Sometimes I don't see the names, but that would be a great question or topic to bring up on the forum. So please do that. I'd love to see and talk more about that. Dan says, full stack as a term and a role name is like saying not generalist. I like that. I may steal that. That's a good one, because you're saying I'm not kind of specialized into front end and back end and data and so on. I'm able to work across all the software, which is kind of what we all should be doing anyway. Certainly that's my old man belief here. I don't quite have too many gray hairs yet, but certainly I think the old way was better, at least in this case, where when somebody wanted the software I worked on first to do something different, they just found a developer. They didn't have to find a front-end developer and a back-end developer and a data person. They found someone who could work across the code. And if we could get back to that, if we could do more of that, we'd be in better shape. One good direction for this, can't remember, there's some goofy name for it, which doesn't make any sense. It starts with ISO something. But there's the notion that maybe what runs on your front end, what runs on your phone or inside your browser, could be the same language as what's running on the server, on the back end. And even you could carry that further, and your data science tools and your models and so on could be in that same programming language. There's some movement toward that. And a typical one is JavaScript or TypeScript. You can use Node.js, which is a tool for doing JavaScript in both locations. And so you can wind up having people who know that programming language, and they don't have that friction. They don't have to learn multiple ones. Although, as I was telling Anastasia, they all kind of speak the same language. It's not that different in most cases. So it's not that hard to translate and to learn and to be good at more than one. But you can make it even easier by making it all one. And the Node JavaScript, TypeScript kind of environment is one place where people do that. Okay, so I'm going to get to this story because I think you guys are going to enjoy it. And it kind of brings together a lot of our ideas we've been talking about here. So I was working with a client. Goodness, this was 5-6 years ago now, and they had a application that did amazing things with maps, and they could put on the maps all kinds of very valuable data that was very interesting and useful to their clients in a specialist area. So I'm obscuring who they were because I'm not going to say very nice things about them. They did not have a good environment. And what had happened to them is they had created these kind of essentially centers of excellence. They had really, really excellent people in 2 different areas who couldn't talk to each other. They hardly understood each other, all in the same office, right? This pre-pandemic, everybody sat right next to each other, and it was as if they were speaking Martian and English. There was just no commonality between the people who deeply, deeply understood maps and understood all the terrible complexities you get with maps, that latitude and longitude don't quite match up, that the scales are different, that a street is on one and not on another, every kind of thing goes wrong when you try to mix many maps together and put a lot of information on this kind of 3-dimensional shape. One of the wonderful complications is the Earth isn't quite a sphere, so it gets quite complicated to understand. Well, there's that kind of extra bump over here, so this mattered to them. This kind of thing, the small deviations from perfect mathematical structures really mattered and would give you the wrong information if you didn't correct for the actual shape of the actual Earth. So anyway, they had these super duper experts who knew everything about this and also knew a lot of machine learning and clever things like that. And they would create these very complicated models that would do stupendous things with maps and data. And they would write those all in Python, in Jupyter notebooks, for those of you who know this kind of stuff. And after they got done with them, it was almost physical. They would just kind of throw them across the room and say, here you go. And the engineers who worked in a completely different programming language, in a completely different mode, who didn't understand maps, and they knew how to show a map on the screen, but they were the ones who were actually producing the software that used the maps. And they would throw this stuff across and say, here's your Jupyter notebook, here's everything. And the engineers would have to rewrite all of it because the engineers didn't understand any of it. It was complete mystery to them. And so they had kind of advanced a pathological form of code ownership where there was a certain set of code, really, really good code, owned by these map people. And they could create anything they wanted. They could do miracles in it, but it wasn't what ran in production. It wasn't what was actually used for customers. What was used for customers was a completely different set of code, which the map people didn't understand, which was really well built and well designed and worked wonderfully, but they had to take everything the map people did and redo it. Well, guess what? This was terribly slow. And they came to me and they said, Squirrel, what problem do we have? Why are we, we have these brilliant people doing amazing stuff and nothing ever gets done. And I said, what you have to do is put these people together. What you have to do is stop having this ownership where there's a completely separate team that does the sort of main value of the company. They're producing the insights that your customers are paying for. And there's these completely separate people who are presenting it in a way that's actually usable, and never the twain shall meet. That can't continue. They didn't take my advice. So they didn't make any real shift in how those people work together, at least as far as I know. And they continued to make very slow progress. And I just checked on them, and they're still in business and they're still running along, but not nearly as dominant in their field as they could have been, not nearly as innovative as they might have been, because they had these highly academic folks who were thinking in very pure terms about maps and weren't interested in the sort of messy, grotty world of display. And vice versa, the display people said, well, the map people do whatever crazy stuff they do, and they're always wrong and never makes any sense to us, and we don't understand it, so we always re-implement all of it. And of course, they got it wrong. So please don't become like this company. That's my message to you. Leverage the tools that we've talked about. You can see this happening. You can look out for people like John who are, kind of specialists. You can look out for places where individual developers or individual teams are always the ones who work on something. Nobody new can work there. That's the kind of symptom. When you have that symptom, get more seniority on the problem, get people pairing, get them writing tests, see if the AI will give you a signal, and certainly make sure there's refactoring happening as you go, that tiny little refactoring to improve as you go to make it more and more comprehensible. And what you should see is then you do not have this kind of throwing the solution over the wall. I can't understand it. It's only what they do. And so it's not my fault, Gov. Go talk to the people on the other side of the room. What you'll have is engineers who are actually able to collaborate across the organizational boundaries and who increase their knowledge and increase the quality of the design of your code. So I hope that's helpful. We had some great questions. I really appreciate that. There'll be more discussion on the forum. I would love to see you at future events. And let me just put up where you would go to do that, because we have lots more exciting stuff happening. And that's at Squirrel Squadron, except I can't spell squirrel. That seems like a problem. I should probably know how to spell squirrel. Squirrelsquadron.com. Put that up on the screen for you, because I would love to see you at more of these events. I'd love to see you on the forum, and I'd love more of these great questions, especially that one person who asked a great product question. Please put that on the forum, because I sure would like to talk more about that. Dan says, where were people submitting questions? You're on YouTube, and I can see it there. We're also on LinkedIn and Facebook. We never seem to get any questions from Facebook. Probably there aren't that many developers left on Facebook. I don't know. But the answer to your question, Dan, is LinkedIn and YouTube. And I'm happy to see you on both, or neither, or anywhere else. And please join the forum, come on to further events, and ask more of these fantastic questions. It's been wonderful being with you. Have a wonderful day, and I will see you next week at the next event. Have a wonderful day.